Hi, Honors Math 9. Today we're going to start a new unit called Systems, and today we are going to solve linear equations by graphing. And it might be useful to have your graphing calculator with you. If you don't have a graphing calculator, that's okay. I'm also going to show you how to use a computer website called Desmos that's going to act as a graphing calculator for you.
Alright, before we start solving systems of equations, we have to know what they are. So a system of linear equations is when you have two or more linear equations that use the same variables. So in this example, our system of linear equations is the equation x plus 2y is equal to 6, and then 4x plus y is equal to 5. A solution to a system of equations is when you have an ordered pair or multiple ordered pairs that satisfies all equations in the system. Alright, after just definitions, our first example is to test whether or not the given point is a solution to the following systems. So again, if it's going to be a solution, it's going to yield a true statement for each of those systems. So is the point 2, 4 a solution? Let's start first with A to the system. So what we have to do is plug in the point 2, 4 in for x and y and see if it's a true statement. So when we do this, does 4 equal to 5 times 2 minus 6? Well, 5 times 2 is 10. 10 minus 6 is 4. 4 is 4. Is 4 equal to 4? Yes, it is. Then, since it works for that one, you still have to test the second one. Does 4 equal 1/2 of 2 plus 3? 1/2 of 2 is 1. 1 plus 3 is 4. So does 4 equal 4? Yes, it does. So yes, the coordinate point 2, 4 is a solution to this first example, A. In B, we have to try it again. So again, let's plug it in 2, 4 in for x. Does 4 equal 2 times 2 minus 8? 2 times 2 is 4. Minus 8 is negative 4. So is 4 and negative 4 the same thing? No, it's not. As soon as you get no for one, you can come up with the justified statement that no, it's not a solution, because it has to work for both equations or all the equations in the systems, not just some. We have three options when it comes for our answers when we solve systems of equations. Our first one is you could have one solution. One solution occurs where the two lines intersect. So if this is line 1 and this is line 2 and these 2 points cross and intersect at this point, that coordinate point, whatever that point is going to be the solution to that system. You could also give me an answer of infinitely many solutions, and this is when the two equations are the same line. If you went to go to graph them and then they're same line, infinitely many solutions, meaning any coordinate point on this line would satisfy and make both equations in that system true. No solutions would be if the lines don't intersect at all, meaning that you have parallel lines. So parallel lines, they never cross and intersect, meaning that there's no possible combination of xy coordinate that would work for both of those equations. These are three examples that we're going to do. Our first one is a system y equals x plus 2 and y equals 3x minus 2, and we have to find a solve in the systems. I'm going to show you this equation both ways, one with Desmos and one with the graphing calculator. The first way I'm going to show you is by using our graphing calculator. So I'm first going to go to the y equals button, and at the y equals button I'm going to type the first equation, x plus 2, and then in the second one I'm going to type 3x minus 2. Then I'm going to press graph, and let's see what happens. You see that the graphs cross and intersect once, so we know we're going to have one solution. So we're going to press second trace to calculate, and we're going to calculate the intersect, hit enter again, and again. Once it sees guess, hit one more time, and there you go. The intersection of those 2 points is 2, 4. If you don't have a graphing calculator, that's okay. I want you to go to Google and type in Desmos. When you type in Desmos, you're going to hit this first one, graphing calculator. Then you can see that it has a graph paper, and on the side over here is where you're going to enter the equation for the first one, y equals x plus 2. And as you are typing, you'll notice over here that the equation's already graphed for you. You're going to go up over here to this add item list, and you're going to do expression,
and type in the other one, y equals 3x minus 2. Or if you hit enter, it'll come up with another one. So it'll tell you that the first equation is in red, the second equation is in blue, and there it is graphed for you. In order to come up with the point where they intersect, if you type it or touch it with your mouse, there it is, 2, 4. Awesome job. So we know that for our first one, our solution is 2, 4. Now I'm only going to use Desmos for the last two. So in my Desmos, I'm going to do the example number 2. We have y equals 2x minus 4. And in the second equation, it's y equals 2x plus 5. Okay, and when we graph that, you should notice that these are parallel lines, and by looking at the equation in slope-intercept form, both of the slopes are 2. So the answer, solution, is no solution. Because they are parallel, no solution. When we do our last example, you have to make sure y is totally by itself. So before we do anything, before we can type it into either a graphing calculator or in Desmos, you have to get y by itself. So I'm going to divide both sides by 2. So I have now the equation y equals 1/2 x plus 1. So y equals 1/2. See how it creates a fraction for you? Move over to the side x plus 1. And then I'm going to type the same thing here. 1 divided by 2, x plus 1. And when you do that, you should only have one graph drawn for you, meaning that the solution, infinitely many solutions. Awesome job. And usually we graph all of these by hand, but because we all don't have graph paper, I want us to use technology instead. Nice job today, guys.